So welcome back for part 3 of the final project recitation. So far you have seen all of the required components for the final project, including path following, path planning and path following, localization and path planning and path following, and mapping and path planning and path following. Today we're going to talk about Escape SLAM, which would be the extra credit part or the part for graduate students, as well as the final report requirements. Remember, if you have any questions about any parts of this, ask your professor and maybe watch it a couple of times to help with some of those parts you're not clear about. Remember, you can make your graphical user interface in any software you want. I've had students make it in MATLAB, in Java, in processing, whatever language you know. If you have never made a GUI before, processing is typically the easiest because it looks very similar to the Arduino IDE. All right, let's get started for part 3 and wrap this thing up. Stay STEM-tastic, stay STEM-rific, stay STEM wonderful. So our next robotics challenge is called SLAM Escape, and this one is optional for undergraduate students and required for graduate students. You use SLAM to localize and create a map of the world. SLAM stands for simultaneous localization and mapping. Then you explore the world that you've created to find a light beacon and report its location back to your GUI. And then the robot implements a coverage and exploration routine around the map that was created in order to determine what has changed. And a wall will disappear from the world, which represents the escape path, and the robot should escape through that wall. And here are 2 examples of Escape SLAM in an occupancy grid, and then again in a topological map. So, as a reminder, you need to always make a software design plan for any major part of your final project. These are all going to be included in the appendix of the final report, and you should refer to them in the methods section of the report when you're discussing how you designed the system to meet all of the challenges. So you should have a GUI mockup, which is a description of the graphical user interface you're going to create, including information like how you're going to send goal data, receive sensor data, send path plans, show paths on the map, receive localization data, receive map data, how you're going to display that. Your second software design plan should be one based upon path following and path planning, where you talk about topological and metric path planning based upon being in an occupancy grid as well as in a topological map. Your third software design plan will be based upon localization and mapping. These can be pseudocode, flowcharts, state machine, subsumption architecture. It does not have to be the same for all of them, but it's whatever you think best represents your design process. And then if you choose to do the SLAM Escape Challenge, you would also have a software design plan for that, where you discuss mapping and localization simultaneously, how you're going to find the beacon and the coverage algorithm for escaping the maze. So the demonstrations that you will be graded on, the first one will be your ability to do wireless communication with your robot, to send and receive data on the robot, and to display that information on a GUI as well as send information from a GUI. Remember, you can choose whichever software you would like to use for that. Your second demonstration will be based upon path following and path planning. Topological path following is where you send in commands like start, right, left, terminate. Metric path planning is based upon wavefront expansion or grass fire expansion. Wireless comm and GUI must still be in use by the time you get to part 2. Part 3 will be based upon localization and mapping, where you will show that given a world, a known world, the robot can localize and plan a path to a goal, where you display the start position, the goal position, and then it goes somewhere in the world. Then you're going to have a coverage algorithm for creating a map. And once the robot has accurately created the map, you can plan a path from a start to a goal position inside that map. Wireless communication and GUI should still be working at that point. And then SLAM Escape is where the robot creates a map, localizes in that world, finds a beacon, and then escapes the maze. And once again, wireless communication and GUI are expected for that part. So your due dates. It is always the Sunday at midnight of finals week. So for 2023, those dates are February 19th. That is the day all demos, whether in person or video, are due by 11:59 p.m. Course evaluations are also due by that date at 11:59 p.m. Whereas if we can get 90% participation, I will replace your lowest quiz grade with 100. All software design plans are due as part of the appendix of your final report. They will be a separate grade, but I will grade them while grading the report. Your final project report and final project code are also due at 11:59 p.m. on that same date. For your final report formatting, just use the default Word document or Google Docs, typically 12-point font, Calibri or Times New Roman or Arial, Tahoma, whatever. All pages should be numbered. You must have a table of contents with page numbers that refer to the main parts of the report. Your paper should be organized with headings, subheadings, clearly noted headings, left, justified, referred to in the table of contents. All figures and tables should have numbers and captions and should be numbered in the text and referred to and described in the text to make it clear why that figure or table is there. As stated, your software design plan should be in the appendix and referenced in the methods section of the text. You should also have any large tables, figures, or images should be in the appendix. You must have images of your final graphical user interface in the appendix. You should also have some images of your robot, ideally somewhere in your report. It could be your robot in the world, your robot on a test stand, but some final representation of your robot as well. Please see the ECE writing guidelines as well as Purdue OWL for more help on proper citations as well as proper formatting for a technical document. Here are the main components I want to see, but you could also have subheadings under here: a cover page, an abstract, a table of contents, the objective, theory, method and results, conclusions and recommendations, references, properly cited and listed using APA format, Chicago MLA, some format, an appendix, and any supplementary materials. The covering page should include the school, the course number, the course title, team member names, robot name, project title, as well as the date submitted. The abstract should be no more than a page, should come after the cover page, and no more than half a page, and it's a brief statement about the final project method, results, conclusions, etc. It's basically like the movie premiere to make me decide if I want to read the rest of the paper or see the movie. The table of contents should then be on a separate sheet of paper with all of the headings, the subheadings, as well as the page numbers. The objective should now be the next section first. It's kind of like the introduction. What is your purpose? Why are you doing this? As a general statement, you should talk about to teach the robot some navigation competencies, but it should definitely be detailed enough so that the reader understands what the robot is meant to accomplish, what your goals are, and don't write it assuming I know anything about your final project. Think about an intelligent 12-year-old. Would they understand your objective? For theory, think about background theory. You need to use 3 sources from papers, MLA, readings, internet sources about things such as SLAM, localization mapping. I don't really want you using your lecture notes as a reference. I don't really want you using my book as a reference. I want to see that you can go online, or you can go to the library, or you can go to Google Scholar and find other references about robotics. You've been reading literature about robotics all quarter. Show me that you can find a technical paper and cite it in this section on something related to what you're going to implement on your robot. Everything cited in the reference list should either be in MLA, Chicago, APA format. I don't really care. Whatever you use in TechCom is fine, but it needs to be in some kind of technical format. Look at Purdue OWL for examples of writing reference lists as well as citations. The methods is like the procedure part of your final report. It's where you talk about how you implemented any algorithms, what you did to achieve your purpose, the procedure for the final project. You would reference your software design plans, as well as your GUI mockup, what you created, how it worked, and how you implemented it. This is the details about what you did. The next section is the results. This is where you summarize all the tests that you did. You answer any questions that I proposed as part of the project. You talk about what went well, what didn't go well. Were you able to achieve your purpose? Were there any errors that you observed? Were you able to solve those? And if not, what do you think you could do to solve them? Or do you have any qualitative or quantitative results? Any images of the robot? I would expect to at least see the GUI, if nothing else. Questions to be answered in the appropriate section. Make sure to state question number and answer when answering questions. Finally, conclusions and recommendations. Based upon the results, were you able to achieve the final project objectives? Were any objectives missed? What did you learn, observe, and achieve? Were there any possible sources of error? We already know odometry and sensor error are big. Mismatched motors are big. There could be bandwidth error from wireless communication, Bluetooth, etc. Any recommendations for improving your implementation of the project? What questions do you still have about the final project? How could you expand or improve on what you did? Once again, you must have 3 technical sources in the references section. They cannot be my book or the lecture notes. They have to be something you find on Google Scholar, you find on the library, a technical website, a technical journal, etc. And here are a few other links for helping to properly cite references. In the appendix, you can include any relevant graphics or tables that are too large for the main body of the paper, but they still need to have a figure number, table number, caption number. Your software design plans are in the appendix. You want to make sure you reference by figure number and description in the main body of the text to help me to understand why that particular item was included in the report. Any code excerpts you think are important, put those in the appendix as well. Software design plans, GUI mockup, any kind of other information, screenshots, hyperlinks to demo videos. If you put your videos on Google Photos or YouTube or wherever, put links here, because sometimes I want to go and look at your demo again to help me with grading and to help me to understand your report. Finally, if one partner writes the report, the other partner needs to read it and needs to read it for clarity, punctuation, grammar, etc., spelling. You're looking for capitalization errors. There is a word and grammar spell checker on Word. You can run it through, confirm that all figures and tables are formatted correctly, that you have page numbers, a title page, all parts of the lab are there, all parts of the report are there. And remember, you're going to be demoing a rolling deadline, weeks 8 through 10. Everything is due the Sunday by midnight of finals week. But as soon as you get things working, you should go ahead and demo, because there are lots of demos and lots of things, and you should be writing your report in parallel the entire time, that 3 weeks that you're demoing, so that it's not such an overwhelming process at the end. Once again, about your code, don't forget, same requirements as on your labs. You need to have a header with partner names, title of the code, what's the purpose and objective of this code. You can have different code for each part of the lab, but they all need to still follow these same guidelines. Summarize key variables and key functions in the header comments. Have block comments and inline comments throughout your code to make it clear what's going on as I'm reading it. It should read like a story to me, so that an intelligent 12-year-old just from the comments can understand what's going on. And with that, we are done. Whew. I know it's a lot. Your goal is to accomplish as much of this as you can. The key to doing that is working a little bit every day, working on the report a little bit every day, working on the demos a little bit every day, and demoing things as soon as you are ready to go, and asking questions when you don't understand something. That software design plan is the key to all of this. You need to use that as your guide and modify it as necessary if it's not meeting the purpose. So remember, ask questions, get help, and keep moving forward. This is not something you want to wait to the last minute to do. You will be up for 48 hours straight trying to get this done by the Sunday of finals week. So what I will say is stay STEM-tastic, stay STEM wonderful, stay STEM awesome, stay STEM terrific. Bye-bye.